Okay, today we're going to talk about complex numbers. Before we do, we need to do just a little bit of review. So I got three problems here, and I want to go ahead and review how to solve them. So the first example is simply adding two linear expressions together. So I got 3x, 3 plus x, and we're going to add 4 plus 2x to it. Now, when it's an addition problem, all you do is you get rid of the parentheses. So you got 3 plus x plus 4 plus 2x. And we're going to combine like terms. And x's combine with other x's. Numbers can combine with other numbers. So remember like terms. So I'm going to add the 3 and the 4, and I'm going to get 7. And I'm going to add the x and the 2x, and I'm going to get 3x. And we're going to leave the answer as 7 plus 3x, because I cannot combine the 7 and the 3x because these are not like terms. All right, now let's move down and look at the next example. The next example is a subtraction problem. And like the addition problem, we're going to want to get rid of parentheses, but we have a problem, and this minus symbol is a big problem. The first set of parentheses we can drop, so it's 4 minus 2x, but the second one we cannot just drop it because this minus symbol actually is going to get distributed. And the reason it gets distributed is because you can really think of this as minus 1, and then when you do minus 1, you have to distribute to both of these. So the minus times 3 is going to be in minus 3, because I'm subtracting 3, but not just 3, I also have to subtract the x. So when we're going to write it without parentheses, the 4 minus 2x is fine, but it's minus 3, and most and critically important is it is negative before the x. That is the number one mistake that gets made here. Okay, it must be minus x. Okay, now just like before, we can combine like terms. So I get a 4 and a negative 3, and that's going to equal 1. And I got negative 2x minus x is negative 3x. So I do 4 minus 2x, take away 3 plus x, you get 1 minus 3x. All right, and then the last example is going to be down here, and this is going to be a multiply problem. In a multiply problem, you're going to use the distributive property, and you actually use the distributive property twice. Sometimes people refer to this as FOIL. That's just a way of remembering the distributive property. I prefer to just call it the distributive property because FOIL only works with linear expressions where you have two of them multiplied together. It doesn't work with higher orders, and the distributive property works with any amount of expressions or terms in here. So we can use it with higher order terms than just two. So I'm going to keep using the word distributive property, but know that FOIL is what is commonly used in a lot of areas. So distributive property says I'm going to take what's here, and I'm going to distribute it to not just the first thing, but both things on the other side. So we're going to do 4 times 3, which is 12, and 4 times x, which is 4x. And then I have to go back and do the same thing with this negative x. So it's also going to get distributed. So we get negative x times 3 is negative 3x, and negative x times x is negative x squared. And simplifying it, we got a couple middle terms here we can combine. So we get 12 plus 4 minus 3 is going to end up being simply x, or 1x, and we got a negative x squared. All right, so now what does all this have to do with complex numbers? And some of you are probably wondering, hey, why is Mr. Brown writing all these backwards? We always write our x's first, and especially down here, we always have the x squared first. I actually did it for a really important reason, and I want you to see side by side what's going on. So we're going to go back through it, and this time we're going to go ahead and do it with complex numbers. So I'm going to rewrite these same equations again. So here, instead of 3 plus x, I'm going to write it as 3 plus I. There's our complex number. And the other complex number that I'm going to add to it is 4 plus 2i. Okay? So I got two complex numbers, 3 plus I and 4 plus 2i. And just like we did before, when we add two complex numbers, you can drop the parentheses. So we're going to drop it and get 3 plus I plus 4 plus 2i. So it's very similar to what we did over here. As a matter of fact, it's so similar that you can even treat the I like another variable like it was done over here. And that's exactly what we're going to do is we're going to combine like terms. And the like terms is the i's get to combine with other i's, and the constant parts get combined with other constant parts. So we're going to do the 3 plus 4, and we're going to get 7. And we're going to do the I plus 2i, and we're going to get 3i. And that is our answer. So our complex answer when we add 3 plus I plus 4 plus 2i is 7 plus 3i, just like it was 7 plus 3x. So this is not really a whole new thing. You just got to understand that you can treat that I like a variable x and do the same things that you've done all along back in Algebra 1. All right, so let's look at the next example then, when we subtract them. So now instead of 4 minus 2x, I got 4 minus 2i. There's one complex number. And we're going to subtract 3 minus I, or 3 plus I, excuse me. We're going to make it the same, so we got 3 plus I. And when we subtract, we have the same problem. We're going to have to distribute that minus symbol. So when we get rid of the parentheses, we still got the 4 minus 2i. But we have negative 3. And we're going to do negative I because we distributed this minus symbol to both the 3 and the I. And now we're going to combine like terms. So we get 4 minus 3 is 1. And negative 2I minus I is negative 3I. Just like it was over here when we had 1 minus 3x. Okay, so there we go again. And let's look at what happens when we FOIL. So we're going to start with 4 minus I, and we're going to multiply 3 plus I to that. So we got two things multiplied together. Just like before, we're going to use the distributive property. So the distributive property says I start with what's out front, the 4, and multiply it to both things in the other term. So we got 4 times 3 is 12. We got 4 times I is 4i. Okay, so exactly like we had over here. But we're going to go back, we got to finish it, so we got to distribute the negative I. So I got negative I times 3 is negative 3i. And lastly, negative I times I is negative I squared. Okay, and then we can combine some middle terms, and we get 12 plus I minus I squared. Now, right now it's identical, but this is where it's different. I squared is something very special, so we need to take a break, and I'm going to look back, and I'm going to erase the left side here. So before I do, I really want you to emphasize how similar what we've done in the past is to what we're doing right now. You can so far treat I exactly the same way, and anytime we're solving with I, we're going to treat it the same way. And there's a very specific exception that I'm going to show you right now. So let's go ahead and erase this right-hand or left-hand side, and let's talk a little bit about what I actually is, because that's where the special case is going to come in. Okay, so first we're going to look at what I is, and we've defined I to equal the square root of negative 1. And that's by definition. There's nothing magic about it. We have defined it to be the square root of negative 1. But I now have this thing called I squared, and I need to know what I squared is. Okay, because we just came up with an I squared, so how are we going to do that? Well, we're going to square both sides. So if I square I get I squared, but I can do the same thing on the other side and square that. So all I've done is I've squared both sides, and I get I squared, and on the right side I'll get the square root of negative 1 squared. Well, we know what I squared is, but anytime I see a square root and a square together, they cancel each other out. So the I squared is simply negative 1. Okay? As a matter of fact, I'm going to write it over here on the left side so you can see it. So I squared is just the number negative 1. It's no longer imaginary at all, which is very surprising that if you square an imaginary number, you actually get a real number, negative 1. So I wonder what would happen if we did it again. So let's end up seeing what I cubed is. Well, in order to get I cubed, I need to multiply I squared times I, because when I multiply these two things together, I'll end up with 3 i's. So we're going to multiply I squared times I. So I'm going to show it over here. This is the same as I squared times I. And we agree that that's I to the third power. So it would make sense that instead of I squared, I could use negative 1, because I squared and negative 1 we just showed are exactly the same thing right here. And instead of I could use the square root of negative 1. Actually, I'm not. I'm going to leave it as I, because that's the way we normally see it. So we're going to leave it as I. And when I multiply negative 1 times I simply get negative I. We don't have to write that negative 1. So I cubed is known as negative I. So first one was just I. That's by definition square root of negative 1. And when I square it, I get negative 1. As a matter of fact, just for simplicity, we're going to say I is I. I squared is negative 1. I to the third power is negative I. And let's do it another time and see what happens. And if I want I to the fourth power, what I really want is I squared times I squared. Because I squared times I squared is I to the fourth power. Well, I squared is negative 1. And I squared again is negative 1. So we're going to be multiplying negative 1 times negative 1, and that is positive 1. So I to the fourth power is positive 1. And just to show you that this isn't a trick, we could have also done I to the third times I. Well, I to the third, as we just decided, is negative I. And I to the first is simply I. And when we multiply negative I times I, we'll get negative I squared. And we just decided I squared is negative 1, so this ends up being negative 1, which of course is also 1. So this isn't a special trick because I picked I squared. It doesn't matter what you pick. I to the fourth is always 1. So we could keep playing this game, and let's do it one more time. And we want to find what I to the fifth is then. So we're going to take I to the fourth, and we're going to multiply it by I. So I to the fourth, as we just defined, is going to be 1. We're going to multiply that by I, and we simply get I. So I to the fifth is back to I. And if you notice that we've had a pattern now forming, we could do it again, and we'll end up with I squared, which is negative 1. So I to the sixth is going to be negative 1. I to the seventh will be negative I. I to the eighth is going to be 1. I to the ninth comes back up here and is I. I to the 10th is negative 1. I to the 11th is negative I. I to the 12th is 1. And then we go back up again. So I to the 13th is I again. And it will go like that through that cycle of these 4 all the way to infinity. So anytime you see an I or a power that is similar to it, so 1, 5, 9, etc., it's I. If you see the squares, or the ones that would follow in the pattern, which would be 6, etc., you get negative 1. I to the third is negative I, and I to the fourth is always going to be 1, so that'd be 4, 8, 12, etc. And these would be the ones less than that, so 4, 7, 11 are all going to be negative 1. Now, we're going to go back over to our problem that we were just doing, and we're going to use that information. So instead of negative I squared, we know that I squared is now negative 1, so I can rewrite that as 12 plus I minus, and instead of I squared, I now know it's to be negative 1. So now I got negative 1 is the same thing as plus 1. Let me get rid of this arrow because I'm going to change it around. Okay, so I'm going to finish it over here. So I got 12 plus I plus 1. Well, I can now combine 12 and 1 and get 13. So the best answer is 13 plus I. Okay? So the only difference is when you see this I squared is we don't leave it as I squared like we would have with X squared. We can actually make I squared a negative 1, and then we can simplify. Your complex numbers will always be in the form of, let me change our color first, A plus BI. They're always in that form where A and B are going to be integers, like they are here, okay? And I stands for that imaginary number, so I is always there. And then A is called the real part, and BI is called the imaginary part. So we have a real part, we have an imaginary part, and together we call this thing a complex number. Okay? So anytime you're going to add complex numbers, you'll get another complex number. Anytime you subtract them, you get another complex number. And anytime you multiply them, you still get a complex number because of the special case of what happens with I squared. So if you don't have this written down already, you really need to make sure you write this down. This is not something I'm going to be giving you on the test. I expect you to know this and memorize this. And the reason I do is because this is very handy information on the SAT that they likely will not give to you. So it is really important that you memorize this. Now, I don't care if you memorize it by just memorizing the pattern, that it's I, negative 1, negative I, 1, or you memorize how to come up with the pattern, but you need to know this information. It will not be given to you. All right, so that's where I'm going to stop today. So this is all about adding. So we've covered adding, we've covered subtracting, and we covered multiplying. Okay, so go ahead and practice with these, and if you have questions, please make sure you ask.